Hello friends, on my channel you can also see videos for inorganic chemistry topic, physical chemistry topic and also industrial chemistry topic which are most useful for upcoming exams. For those videos subscribe my channel. Also check the description box, like and share the videos to your friends also. So let us start multiple choice questions from topic the solid state. First question, dot dot is considered as fourth state of matter. Friends, you are well known about the states of matter are solid, liquid and gas. Here asked fourth state of matter. Options are liquid, gas, plasma, Bose-Einstein, condensate. So correct option is option C, that is plasma is considered as a fourth state of matter. Next, dot dot is the fifth state of matter. So Bose-Einstein condensate is considered as the fifth state of matter. The force of attraction between solid molecules is very low, high, moderate, none of this. So correct option is B, that is high. Force of attraction between solid molecule is very high. Types of solids are crystalline solids, amorphous solids, both A and B, none of this. Correct option is both A and B, C. That is types of solids are crystalline solid and amorphous solid. Glass, rubber, plastic are examples of dot dot solids. Crystalline, amorphous, both A and B, none of this. So glass, rubber, plastics are example of amorphous solid, while NaCl, KCl, that is sodium chloride, potassium chloride, zinc sulfide are examples of dot dot solids. Crystalline, amorphous, both A and B, none of this. Correct option is A. NaCl, KCl, ZnS, etc. are example of the crystalline solids. Dot dot solids have definite geometrical shape. Crystalline, amorphous, both A and B, none of this. So correct option is option A, that is crystalline solids have definite geometrical shape. Next question, dot dot solids have no definite geometrical shape. So amorphous solids have no definite geometrical shape. Dot dot solids are called supercooled liquids. So amorphous solids are called the supercooled liquids, while crystalline solids are called the true solids. Remember that. Dot dot solids are isotropic. So amorphous solids are isotropic, while crystalline solids are anisotropic. Three-dimensional arrangement of atoms in space is called as dot dot. Space lattice, lattice point, lattice plane, lattice unit. So correct option is A, that is space lattice. Three-dimensional arrangement of atoms in space is called as space lattice. It is also known as crystal lattice. It is also known as crystal lattice. Next, the position occupied by a point or particle in crystal lattice is called as dot dot. Space lattice, lattice site, lattice plane, lattice unit. So correct option is option B. That is, it is called as lattice site. It is also known as lattice point. Lattice site or lattice point. The position occupied by a point or particle in crystal lattice is called as lattice site or lattice point. The angle between two intersecting faces is called as dot dot angle. Cone, interfacial, right, acute. So correct option is option B, that is the angle between two intersecting faces is called as interfacial angle. Next, the points in a space lattice can be arranged in a number of parallel and equidistant planes are called as dot dot. Space lattice, lattice site, lattice plane, lattice unit. So correct option is C. It is known as lattice plane. The points in a space lattice can be arranged in a number of parallel and equidistant planes are known as lattice plane. The interfacial angle of the same type of crystal is always constant. That is option D. The smallest sample of crystal is called as dot dot. Space lattice, lattice point, lattice plane, unit cell. So correct option is D. The smallest sample of crystal is called as unit cell. It is also known as lattice unit. Lattice unit. Dot dot is the branch which deals with geometry, properties and structure of crystalline substances. Polarography, crystallography, stereography, none of these. So correct option is crystallography is the branch which deals with geometry, properties and structure of crystalline substances. The laws of crystallography is the law of constancy of interfacial angles, law of rational indices, law of crystal symmetry, all of these. So correct option D, all of these. The laws of crystallographics are law of constancy of interfacial angle, law of rational indices, law of crystal symmetry. The instrument used to measure the interfacial angle is known as voltmeter, thermometer, goniometer, none of these. So correct option is C. The instrument used to measure the interfacial angle is known as the goniometer. The total number of planes, axis and center of symmetry is called as dot dot of symmetry of the crystal. Elements, atom, molecule, none of these. So correct option is option A. The total number of planes, axis and center of symmetry is called as elements of symmetry of the crystal. If the crystal presents the same appearance when it is rotated through 180 degree, then the axis is called two-fold axis, three-fold axis, four-fold axis, six-fold axis. So if the crystal presents the same appearance when it is rotated through 180 degree, then it is known as two-fold axis. That is option A. It is also known as diode axis, two-fold axis or diode axis. If the crystal presents the same appearance when it is rotated through 120 degree, then the axis is called, if 180 degree, then diode, and if 120 degree, then it is known as the three-fold axis or also called as triad axis, and if crystal presents the same appearance when it is rotated through 90 degree, then the axis is called four-fold axis, or it is also known as tetrad axis. While if the crystal presents the same appearance when it is rotated through 60 degree, then it is known as six-fold axis, or it is also known as hexad axis. If in any crystal there can be dot dot center of symmetry, only one, two, many, same. So correct option is A. In any crystal there can be only one center of symmetry. Next question. NaCl crystal exhibits dot dot elements of symmetry 6, 8, 23, 32. So correct option is 23. NaCl crystal exhibits 23 elements of symmetry. Dot dot are the reciprocals of the Vis indices, space lattices, lattice site, lattice plane, Miller indices. So correct option is D, that is Miller indices are the reciprocal of Vis indices. In crystallography, the planes are generally expressed in terms of dot dot. Weiss indices, Miller indices, plane indices, none of these. So correct option is B. In crystallography, the planes are generally expressed in terms of Miller indices. So if you given the Weiss indices, then it can be converted into Miller indices. We see example of that here. Weiss indices of a crystal plane are 1, 1, 1 half, 1 by 2 and 3 by 2. So we know that Miller indices are the reciprocal of the Weiss indices. So here we taken the reciprocal. Here 1 as to 1, 2 as to 1 and 2 as to 3. So clear fraction multiplied by LCM. So here multiply by 3, that is 1 by 1 into 3, 2 by 1 into 3, 2 by 3 into 3. So here we get 3, 6, 2. 3, 6, 2. So for this correct option is D. 3, 6, 2. Same type of example you can solve that by pause the video. So here Weiss indices are given 2, 2, 3 by 2, 1. We take the reciprocal 1 by 2, 2 by 3 and 1 by 1. So clear fractions, taken the clear fractions multiplied by LCM. So here LCM is 6. So 6 into 1 half, 6 into 2 by 3, 6 into 1 by 1. So here we get 3 into 1, 3, 2 into 2, 4 and 6 into 1, 6. 3, 4, 6. So correct option is option D. A crystal plane intercepts the crystallographic axis at the multiples of unit distances 2, 3 and 1. Its Miller indices will be. You can calculate same like before question. Here you given the Weiss indices and calculate the Miller indices. So 2, 3, 1, 2, 3, 1. We take the reciprocal 1 half, 1 by 3 and 1 by 1. So here multiply by LCM, that is 6 into 1 half, 6 into 1 by 3, 6 into 1 by 1. Here we get 3, 2, 1, 3, 2, 1. So correct option is option number C, 3, 2, 1. So 34. A crystal plane intercepts the crystallographic axis at the multiples of unit distances 3 by 2, 2 and 1. You can calculate its Miller indices will be. So here we get Miller indices 4, 3, 6. You can calculate and check that. The cubic system has possible arrangement of simple cubic lattice, face centered cubic lattice, body centered cubic lattice, all of these. So correct option is D. The cubic system has simple cubic lattice, FCC means face centered cubic lattice, BCC means body centered cubic lattice. That is option D, all of these. Then next 100 plane of a crystal is called as dot dot plane, cubic diagonal, cube diagonal, that is cubic diagonal, face. So correct option for 100 plane, it is cubic plane or it is also known as cubic face, cubic plane or cubic face. Next question, if the plane cuts the two coordinate axes and is parallel to third axis then it is called as dot dot plane. Cubic diagonal face. So if the plane cuts the two coordinates, so it can be represented as 110 or 101 or 011. Cuts into two coordinate axis and it is parallel to third axis, then it is represented as 110, 101, 011, and it is called as diagonal plane or diagonal face. And next, 111 plane of a crystal is called as dot dot plane. So 111 plane, it is known as cubic diagonal. Remember that 100, it is known as cubic plane. 110 or 101 or 011, it is known as diagonal plane, and 111 plane, it is known as cubic diagonal plane. The ratio D100 to D110 to D111 is equal to 1:1 upon square root of 2 to 1 upon square root of 3. Then the crystal belongs to dot dot lattice. Then such type of ratio is obtained. Then crystal belongs to simple cubic lattice. That is option A. If that ratio is occur 1:1 upon square root of 2 to 2 upon square root of 3, then the crystal belongs to face centered cubic lattice. That is option B. While if the ratio is obtained as 1:2 upon square root 2 to 1 upon square root of 3, then the crystal belongs to body centered cubic lattice. Then next question, n lambda is equal to 2d sin theta represent dot dot equation. Nernst, Planck's, Bragg's, none of these. So correct option is Bragg's equation. N lambda is equal to 2d sin theta represents Bragg's equation. Face centered cubic lattice is associated with dot dot structural units 3, 4, 6, 8. So face centered cubic lattice is associated with 4 structural unit. NaCl have dot dot structure. Simple cubic, face centered cubic, body centered cubic, none of these. So correct option is B. NaCl have face centered cubic structure, FCC type structure. Also remember that KCl also have FCC type structure, that is face centered cubic structure. In NaCl crystal, each Na plus ion is surrounded by dot dot equidistant Cl minus ion, that is 2, 3, 4, 6. So correct option is 6. In NaCl crystal, each Na plus ion is surrounded by 6 equidistant Cl minus ion. Unit cell of NaCl contains dot dot Na plus ions and dot dot Cl minus ion. So unit cell of NaCl contains 14 Na plus ions and 13 Cl minus ion. Same questions related to KCl. In KCl crystal, K plus ion is surrounded by 6 equidistant Cl minus ions. Unit cell of KCl contains 14 K plus ions and 13 Cl minus ion, that is option C. Unit cell of NaCl is associated with dot dot molecules of NaCl. That is unit cell of NaCl is associated with 4 molecules of NaCl. Same question related to KCl. Unit cell of KCl is also associated with 4 molecules of KCl. And last question, lattices which are constituted entirely by ions are known as dot dot. Unit lattices, space lattices, cube lattices, ionic lattices. So correct option is option D. Lattices which are constituted entirely by ions are known as ionic lattices. So here we completed 50 multiple choice questions for topic the solid state. Thank you friends for watching my video. For other videos, subscribe my channel, like and share. Thank you.